Alright, in the notes for 10.1, we're adding and subtracting polynomials. The beginning part of the notes here start with some helpful definitions that you're welcome to review. We're going to start with question number 1. It says find the sum of each set of polynomials, write your answer in standard order. This word standard order is new. There's a convention in math that says that when we write our answers, we usually put the one with the biggest exponent first, and then the next biggest and the next biggest, so they go in descending order. Adding polynomials is just combining like terms. So if you look at 1a, we found the ones that both had x to the thirds, and we combined those together. 4 take away 3 gave me 1. Then next would be the x to the seconds, so 5x to the second plus 1x to the second would give me 6x to the second. Then would come the x's, so negative 6x and positive 1x would give me negative 5x. And then the 2 doesn't have a buddy, so it just stays 2. So when you're doing this and when you're adding them, you're just looking for like terms. And so on this next one, the to the thirds will go together, the to the seconds will go together, the to the firsts will go together, and then the number stays last. And so you just go through the process of adding them up. Negative 3 and negative 3 gives me negative 6x to the third. Notice that when you add the numbers together, you add the numbers out front, but then you don't add the exponents. So the exponent stays the same. Negative 5x squared plus 1x squared gives me negative 4x squared. Positive 6 take away 1 gives me positive 5. And then on this one, that 4 doesn't have a buddy, so that one will just stay minus 4. When you're doing these, it's tricky because your eyes sort of have to go back and forth between the two different sets of parentheses. You always want to double check and make sure that you match the right ones up. Remember, you can only add them together if they're like terms, so they have to have the same variable and they have to have the same exponent. And so on C, I'll do the same thing. So the squareds will go together, and then the regular k's will go together, and then the numbers will go together. And so on this one, let's see, 3 plus 7 is 10k to the second minus 9k, because negative 11 plus 2 would give me negative 9, and then negative 8 plus negative 6 will give me negative 14. So I'm combining like terms. I'm adding or subtracting the numbers out front, but I'm not adding or subtracting the exponents. The exponents just stay the same. Let's see, the a squareds will go together, and then the ABs will go together, and then the regular numbers will go together. And so on this one, let's see, I'll have 6a squared minus 4ab minus 2. So I'm adding or subtracting the numbers out front, and then I'm keeping the value of the exponent on the variables the same. Number 2 asks you to do the question a little bit differently. It tells you that f of x is equal to this and g of x is equal to this. So the first thing that they wanted us to do was do f of x plus g of x. So we wrote down f of x first, and then we wrote down g of x second, and we put a plus sign in between them. We go through and we combine like terms, and we get this one as the answer. In B, we're being asked to do the same thing, but we're going to put g of x first, and then put f of x second. And so that's what we've gone ahead and done here. We put g of x first, and then we put f of x second, and we put a plus sign in between them. So let's pull our like terms here. The 9x to the third doesn't have a buddy, but these two can combine together, and then these two can combine together. And so adding those up, that's going to give me 9x to the third, negative 13x squared, and negative 13x squared is negative 26x to the second. Negative 5 plus 1 is minus 4x, and then the 14 doesn't have a buddy. And so, it doesn't have a like term that it matches up with. That's what I mean when I say it doesn't have a buddy. And so that'll be your answer to the question there. Question C asks us to compare our answers. It says, does the order in which you add make a difference to your solution? And the answer here is no. Look at our two answers. 9x to the third minus 26x to the second minus 4x plus 14. No, order does not matter. Addition is commutative. You get the same answer no matter which is first. The commutative property says that you can flip-flop, and if you add two numbers in a different order, you'll get the same answer to the question, and that's proven here with our work for A and B. Question 3 wants us to write a polynomial that represents the perimeter of the figure. Remember, with perimeter, you're adding the sides of the shape up. And here we're given a triangle. So we have the three sides of the triangle labeled, and they want us to write a polynomial that represents the perimeter. So I took the first side, and then we take the second side, and then we take the third side. It doesn't matter what order you write them down in, because remember, addition can flip-flop and it's the same. And so on this one, you go through and you combine your like terms, and this is the answer that you get. So let's see, 8 plus 1 plus 10 gives me 19x to the second. 4 take away 5 plus 3 gives me plus 2x. And then the negative 6 is just by itself, so that one just drops down to your answer. Anytime you're being asked to find an expression that represents the perimeter, you're just going to add the 3 sides up, if it's a triangle. And if it has more sides, then you'll add up however many sides it has. On question number 4, you're being asked to find the difference. And so that's what makes these ones be not the same as the ones before. They kind of look almost the same, but if you look in between the two sets of parentheses, there's a minus sign. Anytime you're being asked to find the difference, it wants you to take the first one and take the second one and subtract all of these from the first one. Because they all need to be subtracted, you're going to need to take this negative sign that's in between them and change all the signs of these ones, because you're trying to find the difference of each of these things with respect to the first. This negative sign that's in the middle is going to make the negative 3x turn into a positive 3x to the third. It's going to make the positive x turn into a negative x. And it's going to make the positive x squared turn into a negative x squared. Notice that in between them, too, after I change all the signs on the second part, the minus sign changes to a plus sign. Once this part happens, then it's the same as the question that we just did on the other part of the notes where we added them together. We combine our like terms and we write our answer to the question in standard order, which means descending exponents. On question number 4b, you don't want to start by underlining the ones that match up, because you see that there's a minus in the middle. So this subtraction sign means that all 3 of the signs in front of these 3 terms will change. The first part will stay the same, and then on the second part they'll all change. And so that's what's been shown here. The first part stays the same, the minus sign changes to a plus, and then the positive 3x to the third changes to negative, the negative 8x changes to positive, and then the positive 4x squared changes to negative 4x squared. Once you have the negative distributed, then you can go through and you can match up the ones that you'll be able to add together. And you just want to be careful to make sure you only combine the like terms that can be combined with each other. And so in this case, we match them all up. 5x to the third take away 3x to the third gives us 2x to the third, not to the second. And then 3x squared minus 4x squared gives us minus 1x squared. And then positive 8x and positive 8x gives us positive 16x. And then the 7 didn't have 1 to combine with, so that one just stays 7. So when you're doing these, again, just make sure you only combine the ones together that can be combined together. And in C, again, it's a subtraction problem. So you're going to start by distributing that negative to all of the terms that are inside the second parentheses. Remember, the first one stays the same. The minus sign changes to a plus. And then in the second parentheses, all 3 of the signs change. So this one was positive, positive, and negative, and now it's negative, negative, positive. On this one, we'll go through and we'll combine our like terms, so we'll find the ones that match up with each other. And so what happens on this one is that when everything combines together, everything cancels out, and so we just get 0 as our answer to this question. And so here are the 2 problems written, the 2 expressions written down in the correct order. This is g of x minus f of x. The negative sign here will distribute through to the 3 terms that are in the expression that represents f of x. So my first one will stay the same. My minus sign will change to a plus sign. And then here, all of the signs will change to be the opposite from what they started as. Once that's complete, then I can go through and I can combine my like terms. So here these can combine, and then here these can combine. Combining those terms together, I'll get negative 9x to the third. The negative 13x squared and net positive 13x squared cancel out, so those go away. Negative 5x take away 1x will give me negative 6x, and then the 14 just drops down because that also doesn't have 1 to combine with. In the final question, we're being asked to answer, does the order in which you subtract make a difference to your solution? And comparing these two answers with each other, the answer to that question is yes. If you put F first versus if you put G first, the answers are very similar, but they're not exactly the same if you look at the signs. And so yes, the order matters. Subtraction is not commutative. You get different answers depending on which one is first. And remember, this is different than what happened when we added them in the other order like we did on the front side of the notes, because when we added them in the different order, it did not matter which one went first, because addition you could flip-flop. And so seeing each of these differences helps highlight an important thing, which is that subtraction cannot flip-flop the same way that addition can.